Okay, I think we're actually live now. How about that? A little bit of a technical screw up there, mostly because I was impatient and clicked things too many times. I just want to get this also set up so I can monitor the chat as well, but I think we're okay now, actually. Let's see what's going on. I think that looks like the right screen. Fingers crossed and everything. Anyway, I hope audio is fine. I've been tinkering with some audio settings today too. I notice that sometimes I tend to overpower that. So my apologies if that's a problem. Yeah, there's a problem here. Okay, because I'm flying solo on this, I don't have my wingman with me at the moment. I'm gonna try and restart my monitor for the stream, and then we'll get underway. So we are going to do contingency tables today. Okay, I think we're on. Yeah, I think we are. Okay. So anyway, welcome to stream number 5, lecture number 5 in the Introduction to Statistics series. Yeah, things are working now. I can actually get a little sound feedback there. Cool. All right. So apologies for not being up and online yesterday. Life got in the way on that one. But life didn't get in the way today. So we're going to do, as mentioned, as I promised, we're going to take a look at contingency tables, these guys here. And I'm going to try and get a good understanding of these because we can use these in probability as well, and that, of course, is coming up. The thing to keep in mind is these don't have to be terribly hard questions, but sometimes the way they're worded is a bit ambiguous, unfortunately. I sometimes think, rightly or wrongly, that in an effort to make a challenging question, sometimes profs or instructors make the wording cumbersome because the question itself is really not all that hard. Is that right or wrong? Well, I don't really know. Sometimes I come down, well, most of the time I come down on that's the wrong way to do it, kind of side of that argument. But anyway, that's a philosophical discussion we'll get to another time. So here's a typical 3x3 contingency table. Across the top, I've labeled the columns as A, B, and C. And down the left-hand side, I've labeled the rows as 1, 2, and 3. Now, these can be anything you want them to be. I'm just keeping this very generic. The numbers inside the boxes in the cells, those are merely frequencies. And we have to fill a few things in before we can answer some questions about this. So that's what we're going to talk about. So essentially, you've got two conditions, or two states, if you want. You've got whatever's going on here at the top, and then you've got whatever's going on the side, because you have to identify the rows and the columns appropriately. And if you're setting one of these up yourself from a paragraph or something from a written response, it doesn't really matter who's the row and who's the column, as long as you understand what's what. Now, before we can really answer any of these questions, we should get the row totals and the column totals. Later on in probability, we'll call these marginal values because they appear in the margins of the table. The numbers on the inside are often called conditional values because they're conditional upon some other characteristic. Okay, so let's do row 1. So here we have 15. I'm going to use red for that. So this adds to 15. Row number 2 only adds to 4. And row number 3 adds to 30. And you'll notice there's a box down here at the bottom right. Well, this is where we're going to put the grand total. So that means this has to add up, and this comes out to 49, which is a really silly number for math. So I'm going to make a small edit. Where's my eraser? We're going to turn this 2 into a 3, and that'll make this a 16. And then you'll see why I'm going to do this. Whoops. Undo. Come on, undo. So this will be 16, and I want this to be a 3 because if we observe the total, this is exactly 50, And that makes for easy mathematics. I actually thought I had that worked out, but apparently I can't count. But if you've been following these streams, I'm sure that's not a real surprise. Now we got to do the same thing for the columns. We have to add those up. So this adds to 11. 8 and 3 is 11, and 20 is 21. And this is 18. So these are the marginal values, and you'll notice that they sum to the same value. If you're setting this up yourself and they don't sum down the columns and across the rows to that grand total, then you've missed something. So back up and check, okay? Now, how do we interpret this? Well, we can answer any number of questions here. So let me move that table a little bit. And actually, I'm just going to move the whole thing over this way a little bit. There we go. So what kind of questions can we ask or answer here? Well, let's see. Let's use black ink for this one. Let's say I wanted to know, out of the 50 people, how many were in row 1? Whatever row 1 might be. Row 1 might be Boy Scouts. Row 2 might be Girl Scouts. Row 3 might be I don't know, parents. I'm just making stuff up. But let's say I wanted to know how many people are in row 1. Well, that's easy. The answer to that is 16. It's sitting there looking at us. But now let's say I ask the question, what percentage of the 50 people, those 16 people make up what percentage of the total? So we could say, well, row 1 is what percentage of all? Well, now, this is where the grand total comes in. The answer here is 16 out of 50. And now you'll see why I wanted it to be a nice number. That's 0.32 or 32%. So we can answer questions like this in two different ways. We can just give raw counts, or we can do percentage. Now, what else can we say about this? How about if we look at all the people, how many, or what percentage, let's do it this way, because this is quite often how it's going to be. What percentage of category B is in row 2? Okay, so what percentage of category B is in row 2? So this just suddenly got a bit more interesting now. So category B has a total of 21 people. Okay, so there's your denominator. Now what percentage are in row 2? Well, that's where we look at the 3. So 3 out of 21, well, that's 1/7, and that is 0. Why are my markers not working over here? 1, 4, 2, 8. Because when you do math for a while, you start to recognize certain numbers, and 1/7 is 1428, usually, unless you're wrong. So this would be 14.28%. So that was a conditional, because the first condition was category B. The second condition was specifically row 2. So what oftentimes happens with questions like this is the first condition reduces what's called the sample space. The sample space here is all 50 people, because in the sample space, that is the maximum number. If I asked how many people are involved in this entire study, well, it'd be 50 people out of 50, and well, that adds up to 100%. Well, I guess it's not really addition, that's divides out to 100%. 50 out of 50. Let's move this up a little bit, and let's try and find some better area to write that doesn't have a problem. And move it up just a little bit. Okay, that's not great, but it'll do. Okay, we can ask the question, I suppose. Or we could ask, what percentage of the population, let's call the 50 people our population, we could say, what percentage of all people are in, now we can go A, B, C, I could do 1, 2, 3, but we're going to go A or C. So or means add. So how many people, what percentage are in category A, column A? Well, column A was 11 out of 50. Now, since the word or means add, now we want to know how many people are in column C. Well, there was 18. So that adds up to 29 out of 50. And because the math is easy to work with, that works out to 58%. There we go. Now, there's one more example I want to do here. So the word or, I want to make a note of this for you. Or means, my laptop is acting up tonight. It's being fussy. The word or means add. So let's just try and move this out of here. I've been playing with some of the settings, and it may be that I've caused my own trouble. So the word or means add. If you see the word and that's the next one I want to talk about, okay, that's really weird. There's something kind of strange going on there. Not entirely sure what that's about. Anyway, technology. It's an older laptop, and I've got way too many years of work on this laptop to just casually say, screw it, let's get a new one. Not in the cards right away, anyway. So if the word or means add, then what does the word and mean? Well, it doesn't mean multiply in this context. In the context of probability, it does mean to multiply, but in the context that we're dealing with here, it means we're looking for the intersection. Now, technically, the word or could also mean union, which means to join together two sets. And that's why I just wrote it as an add symbol, because to join together two sets means you just put them together and you're done. I think when we get to the probability section of the course, I'll spend a bit more time on the set theory stuff, but we don't need to worry about that right now. Let's make a little bit of room here. And, come on, everything's fussy tonight. Technology, why are you so hard? Okay, let's go over here. Let's try writing over here then. Okay, we can ask what percent are, yeah, see, we're still lagging tonight, are in category B and 3. Now, this is really simple. The word and here means the intersection. And if you think about this, the analogy to roadways is perfect. The intersection of category B, well, let's look at category B. Let's get a different color here. Let's use the red one. No, we'll use the green one. Okay, so column B, or category B, is this column. And row 3 is this row. Well, you'll notice this is the intersection of the row and the column, which is our answer. 10 out of 50, which is 20%, or 0.20 if you want it in decimals. So this is the idea that we want to keep in mind. Ands are intersections. The word or, let's write it here. put some air quotes on that. Or means add or join together. Okay. That really is all there is to this. The only thing that can make this question, or this type of subject, any more difficult would strictly be wording it in a clumsy manner or an ambiguous manner, which goes back to what I've said in a couple of lectures now about statistics at this level is about a careful reading. It's all about careful reading skills. The arithmetic's not that hard. Let's look at the next slide. So this is a page out of my textbook I've written for this course, which is available on our Patreon, by the way. I did notice a couple of things I want to clear up, though. I did notice a typo I want to fix up, but at the same time, this is how I wrote the book using LaTeX. Anyway, let's get back over here. We'll go back to red. Okay. Now, example 34. Here we have a table listing the number of students in a faculty, and it also indicates whether they're males or females. So here's our two conditions. We have sex, male or female, and faculty that they're enrolled in, forestry, biology, or science. And the requisite numbers. You'll notice the column totals and the row totals are already included. So this is our breakdown. So this is hardly any different than the table that we saw in the previous slide, just a little neater and just a little bit shorter. The other one had 3 by 3 dimension. This one's a 2 by 3, so not the end of the world. Anyway, do I have the questions on this page? Let's scroll this up. Why, yes, I do. So if we use this then as a learning tool, let's look at question number 1. What percentage of students are male? So that's just this column, right? Here we have 80 out of 200. Right. So there's 80 out of 200, and we get 40%. What percentage are female? Well, we can get that two ways. We can do it the same way. Here's 120 out of 200. Or I can go, well, wait a minute, there's either males or females. And if 40% are males, then 100% minus 40% are female. So there we have a actual, there's another property from probability. It's called the complement rule. If you add up all the possibilities in some event space, you end up with 100%. All right, so that's how we do that one. Let's take a look at question 2. What percentage of students are in the forestry faculty? Now, I didn't specify the sex, so we have to consider both male and female. Well, in forestry, there is an even number of males and females, which of course adds up to 50. And 50 out of 200 is 25%. What book is this? Oh, this is mine. I wrote this over the last number of years. This is, it's about 400. This is really what's called a problem book. I teach in it, but most of the learning in this book is oriented around problem solving. So, for instance, these are examples where I've worked out the solution right away, but as you're going to see in the next set of slides coming up, I've made an effort to, I'd say there's well over 200 problems. So the problem is stated on a page, and I want you to work through what I showed you in the earlier bits. And then when you want to check your answer, you merely just click to the next page, and there's your answer. It's fully indexed. There's an index, table of contents. It's all hyperlinked. So this is available on our Patreon. And if you go to Patreon and search the Tutor Wizard, you will see that there. It's entirely in PDF file. I got a calculus book up there too. So let's take a look at number 3. What percentage of female students are in the forestry faculty? Well, all the female students, there's 120 of them, but we just want to know what's the percentage of forestry out of the 120, and now we get this. just a little bit under 21%. And these are pretty much typical of exam questions too, I think. I do know that on the stats labs, which you should be hearing about pretty soon, this is usually part of the first statistics lab as well. Let's look at the next page. So here, I'm extending some of the discussion. I've brought the table itself over. This is the same table that was on the other page. How many males are in biology? Okay, well, here's your male count, 40. But if I asked what percentage of the biology students are male, then we would have this. So I probably could have worded that question a little better. So let's say the question is, of all the biology students, what percentage are male? Percentage of bio students are male. Well, we have 40 males out of 100. So we get 40 out of 100, which is an easy 40%. Boom. Now, again, I did the how many thing again here. So let's turn the word many into percent. What percentage of females are in science or forestry? Okay, females in forestry, we have 25 out of 50. Now, let's look at the science faculty. There are 35 out of, that better be a 50 there, I can't tell. Let's get my eraser. Right, out of 50. So that's 35 out of 50. So this adds up to 60 out of 50. And what? Not 60 out of 50. I just made a boo-boo. So 25 out of 50, we can't do the common denominator here. This is why I never get 100% on anything. It's just bad, 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 bad. Let's get rid of this. Let's turn this into a percentage first. All right, so this is 0.50. Okay. And, oh, I know what I forgot to do. I know how this goes back to that weighted mean thing we were talking about on the previous, I'm not thinking very well tonight, on the previous lecture. So we had 25 out of 50. This was forestry. Let's write this out right. And then we had 35 out of 50 for science. So what do we do with this? We combine it carefully. This is that adding part. But you'll notice that there's 50 people in this and 50 people in this row. So now there's 100 people. The numerator adds to 60, so this works out to 0.60, or to answer the question in percentage, 60%. Okay. Now, we could have answered that question a little bit differently, too. If I wanted to know, what does that represent if we consider the fact that there are 120 females? So an alternative way to ask this question, and the alternative answer is, if I have 120 females and 35 and 25 and 60 of them are in science and or forestry, pardon me, not the and, the or, then we end up with 0.50 or 50%. So now we're back to chasing around. Ah, yes, you are right. Thank you, Lazoma. You are correct. That's why I'm doing both answers here. You are correct. So if we're talking about 60 out of 120, if we're talking about of the population of females, 120 in this school, and I want to know what the percentage of those are in science or forestry, we get this answer here. However, the way I poorly worded it over here, what percentage of females are in science or forestry, then we end up with your correct answer, which is, or the other, well, the correct answer for this question is 25 and 35 out of the 100. So we have a percentage here and a percentage here. So again, I'm bit by my own question. I kind of typed these out thinking, oh, let's just do this question, let's do that question, let's do the other question. And I really didn't review that one very well. So I apologize for that. Anyway, the point is, careful reading gets you to the answer. Anyway, let's look at this last one here. So this one is a conditional, and these are the ones that usually get people. They're really kind of fun, though. Given that a student is in forestry, what is the chance? So now I'm introducing a little bit of probability, but what is the chance they are female? Well, so the first thing that happens, you see this with the phrase given that. So given that is a way to reduce the population of interest down. Right now the population at the start is 200 students. But as soon as I say the student is in forestry, those 200 students reduce to 50 because we're not interested in the students that are in biology. We're not interested in the students who are in science. So given that a student is in forestry means the denominator changes from 200 down to 50. Now, the second condition is what is the chance they're female? Well, how many females are in forestry? 25. So that's that. And then we get 0.50. So if we're talking about probability, I wouldn't turn this into a percentage. I would just leave it at that. So given that a student is in forestry, so that changes the total sample space, such a hard phrase to come up with. Ugh. The sample space reduces from all 200 students just to 50 students. Because we certainly aren't interested in the males either here. We're only interested in the females, the 120. So given that a student is in forestry, so the original, if I look at just given that a student is in forestry, there's a total of 50, but only half of them are female, so that's where we're getting the 0.5 from. Okay. Let's move on to the next slide. We're going to use another slide out of my textbook here as well. More of the same, really. I'll probably revisit this stuff too. So here we have example 36. Slightly different table, very similar to the one we just saw. This format, determine the distribution of students taking one or more than one class. So you'll notice that the science faculty has been replaced with mathematics. And we have a different layout on the table here. Now, you'll also notice this is one of these weird tables where if you look at the main diagonal here, whoops, where's my marker? This is symmetric across the diagonal. Here's 20, 20. Here's 30, here's 30. It's an artifact of how I built the table when I was using software. So don't panic about that. Now, this should allow us to do and. Here's forestry and biology. And so single class enrollment is found where the same row intersects the same column. All right, so 10 students are in forestry only. That's what we have here. In forestry and biology, we have 20 students. And in forestry and mathematics, we have 20 students. So there's our 50 from before. Now in biology, there's a total of 100 students. So let's check it out. In biology and in forestry, there's 20 enrolled in both, taking courses in both faculties. Only in the faculty of biology, we have 50 students. But biology intersecting with mathematics, there's 30 students, and this adds up to our previous 100. Now, this says nobody is taking mathematics strictly as the only subject or the only program in this school. So anybody who's taking mathematics in this school then is blending it with either forestry or biology. There we go. Now, I would like to do forestry and biology. So, what I'm getting at here in point number 2 is what was discussed. So this table is laid out differently, remember. Notice this is forestry, biology, mathematics across the top. Back over here, we had forestry, biology, and science, then males and females. So 2 different tables to get 2 different pieces of information. Okay, let's look at problem 37. I want to scroll down to that here, because now we have some problems we can look at. Now, there are 100 students in biology. How many are taking mathematics as well? What percentage of biology students also take forestry? How many forestry students take mathematics? And what percentage of mathematics students take forestry? So what we do to get to that, we'll just go over here and take a look. So I've copied the information from the table here, and here's our solutions. Yeah, no pure math students. This is one of those. I don't want to use the word vocational, so I don't want to use the word trade. This is one of those polytech schools where mathematics is absolutely necessary for any of the disciplines you study, but it's always a tool in those disciplines. There's a name for schools like that, and I can't quite remember what it is. No matter. I know in Europe they're usually, I'm thinking of what is TUM in Munich. I'll look it up online later. Anyway, I guess we'll just call them vocational schools, trade schools, tech colleges. Anyway, let's answer the questions. So there are 100 students in biology. How many of those are taking mathematics as well? All right, so here's biology. Here's mathematics as well, and we see 30. How come there we go. My laptop's not being happy tonight. Okay. So this is just a exercise in reading the table and reading what the question is asking you to come up with. What percentage of biology students also take forestry? Okay, so here's the biology row. Here's the forestry column. And, oh, no, not that one. Take biology as well. There we go, 50. Did I get that right? There are 100 biology students. That's right. There we go. What percentage of biology students? So we need all the bio students. So there's 100. And how many also take forestry? That's where the 20 goes. We get 20%. Let's take a look at forestry students taking mathematics. So here's forestry. Well, there's forestry too, but at the end of the day, we got 20 out of 50. I have worked with students from the forestry faculty at the university where I work at, and there's some very interesting mathematics involved with, say, you want to estimate how many board feet of usable wood is in a tree lot. There's methods to figure that out. It's really interesting. I know this is kind of silly, but you usually measure the circumference or get the diameter of the tree at chest height for the tree. So basically, you're hugging the tree, hence the name tree hugger. But when you sample the different species in the tree lot, you determine a percentage, and you can actually make an estimate, a good estimate of the species distribution and the amount of harvestable wood from that tree lot. There's also some other very interesting, and I haven't seen these problems in quite some time. I do have them archived though. They are very interesting. If you want, besides just doing a species count, or a diversity survey for trees. You can do it for insects or animals, whatever. And you get what you do is there's some methods for laying out um, a route through the, say, the tree lot in the case of trees, so that you get random samples. The whole thing is very fascinating and very interesting. I would very much like to know the history of how a lot of that was developed, but trying to find good sources, historical sources for the development of these methods has, well, I haven't found the right book yet, and I have gone looking on occasion, but it was one of those things. We have a good library. I'll keep digging around. Anyway, number 3, how many forestry students take mathematics? Well, we already did that one. That was 20 out of 50. What percentage of mathematics students then take forestry? So here's our mathematics students. This one works out to 40% as well. Again, that's just an artifact of the numbers I used to put this together. Anyway, let's move on. Part of my problem is I'm currently zooming this. I wonder if I reduce the zoom on this, maybe that'll fix my drawing problems. Can I sketch over here any better? Still a bit of a lag. Anyway, not a problem. I'll sort that out before next session comes up. Let's look next. Okay, so that's about all I have ready to go for tonight. Again, it's a bit of a short one tonight. If you're looking to find us on the internet, and when I say us, is myself and Adrian and Lorenzo. There's 3 of us, so you can pick your wizard. I'm an old school computer user, and I remember the dark days of Microsoft and their wizards in programming and some of their other software offerings from back in the 90s and earlier. So it always conjures up, and no pun intended, image of their idea of a wizard. Anyway, we are on Patreon, which is where you will find my books. We're on YouTube, where this video will end up soon. And we're also on Discord, and I do like to throw up a fair curated selection of STEM, science, technology, engineering, and mathematics, memes, etc., etc. And as far as Patreon goes, search for the Tutor Wizard, or if you want our user ID, well, there it is right there. And by all means, if you want to help us out a little bit to pay some bills, there's various offerings on Patreon where you could do that. Anyhow, this isn't the last we'll be discussing of contingency tables. No, not by a long shot. We'll be doing more of them. I'll probably do a few more on the next stream, which will be coming up in a couple of days. I believe Lorenzo will be doing a stream tomorrow. I haven't verified that with him, so just check the Discord or check for notifications on that. But I will have another session for statistics coming up, and I will talk more about contingency tables and a couple of other topics as well. I want to try to get a handle. And, okay. Lorenzo, any hints on what you're going to be talking about tomorrow, or are we going to leave that open for tune in and find out? Lorenzo just joined us on the Twitch chat, so give him a chance here to type something up. Anyhow, these are coming up. We'll be working through some more linear algebra problems. Cool. One of these things we should do on the topic of statistics and linear algebra. Where's my pen? So here's one I would like to do. And we'll do this in a simple manner. So if I've got, so let's say we're doing bivariate data, so x and y values for scatter plots, right? And I want to know the correlation between two, it doesn't necessarily have to be scatter plot. If I want to know the correlation between, say, vector A, which is the values 2, 0, 3, and vector B, so A could be the y values and B could be the x values. Well, it turns out that R, the coefficient of correlation, is just the cosine between the angles, or the cosine of the angle between vector A and B. So there's something to chew on. Anyway, I'm not sure exactly what Lorenzo has ready to go, and we'll find out tomorrow. And we'll get Adrian back in the saddle again after he's feeling healthy to do some more of the history of mathematics. That's still to come this week. Okay, I think that's enough blathering on from me. You folks, thank you for putting up with my shenanigans tonight. I know we got off to a false start with a little technical screw up. My laptop is misbehaving a bit, but that's not the end of the world. Anyway, thank you for tuning in tonight, and we'll talk again very soon. Bye-bye now.